So the process of improving your model can can go as long as you have the ideas to tweak your model, the resources available, and of course the time available, right? So you can play around with improving your baseline model by tweaking the hyperparameters of the CNN, by adding more convolutional layers to the CNN, by adding more fully connected layers to the traditional neural network part of the CNN, and so on, right? But once you decide your final model, that is the model which gives you the maximum performance on your data set, it is time that you will save that model, right? So once you have decided on your final model, you should always save your model, so that the next time when you close your Jupyter notebook file or the Spider file, you don't have to rerun your entire program, but you could just make prediction on top of this saved model. So while in production, what we do is, once we have decided on our final model, we will save our model and we will use this saved model to make predictions. So in this video, we will see how to save the model, and I will show you an example wherein which I give a new image, and I will make we will try to get the prediction of which class that image belongs to. So let's get started. So this is again the CNN on our Fashion MNIST dataset. So in my first video, I have built a baseline model for my Fashion MNIST dataset. In the second video, you could see me performing some iterations on the base model to see if I am getting an improvement in performance. Now, for this particular dataset, I found that the base model itself is working very well. So I have decided to now save that model. So you could see all the part of the code is the same, wherein which I am loading my data set, I am preparing my pixel, I am defining the model, and for the model evaluation part, here you could see I am fitting my model. I'm fitting my model. That means I'm actually doing my training. So as you can see in this, I'm not using a cross validation, but instead, since I have already decided that this is the model I will be saving for and I have finalized, what now I am doing is I'm giving my entire 60,000 data points for my training, right? So that's why I haven't included my k-fold cross validation, because after doing a k-fold cross validation, I have already got my performance value. And so while saving your model, I wanted my model to be trained and saved for the maximum data point that I have, right? So as we know, our Fashion MNIST data set had 60,000 points. So I want 60,000 point in the training data set. So I wanted that whole point to be used for the purpose of training and thereby saving the model. And as you can see, the only extra line of code I have added is here. So I just wrote model.save final underscore model.h5. So when I run this particular program in my laptop where this program is saved, in that folder you will get a file with the name final underscore model with an extension of h5. So I have saved my model. Now let us see how to make prediction from this saved model file. So this is the program for that. Here you could see that I am giving a image for prediction which is called by the name sample image. So this is the sample image I am using, and I wanted to know in which class or category this image belongs to. So as you can see, since I already have my model saved in my laptop, I just have to load that model by calling load_model within bracket that model name, right? And then an if-else statement to give my corresponding label name for that particular class. So let us go ahead and run this. So as you can see, when I run that code, I get a plot of my actual image, and here you could see the class which it belongs to, which is pullover, and that's a correct one. So from the library, Keras library or TensorFlow library, I know that these images are in the category of pullover. So what my model has predicted is actually the correct class for that particular example. So this is how you should work with your coding activities, in which you develop first a baseline model and then tweak those baseline models to come up with some advanced model, and see from these baseline model and from the different advanced model you have created, which is the model that gives you the best performance, and then decide that to be your final model, and then save that model. And once you have that saved model, you can start making prediction on that saved model.